my screen. Mm, okay. So as I was explaining to the others, I was saying we're going to continue with algebraic expressions, applying the laws of exponents and everything. But today's lesson is going to be mainly focused on the laws of exponents, right? And let me share my screen so you guys can see. Mm, you guys able to see? Or do I need to rotate my phone? You guys able to rotate? Guys, are you able to see?
Yes.
Okay. So we're gonna start with the first question over here. Remember, I said the main focus for today's lesson is gonna be on the exponent, anything that has to do with expressions, how to get rid of the square root. Remember, recently we learned how to remove the square root or the square root or cube root or fourth root or nth root, right? So we'll be basically dealing with those kind of questions, right? And I've got this question over here. This is in preparation for your June exams, right? And the first question over here, or the first task that you need to complete, the same match column A to column B. Write your answer in the column provided, right? And then we have 5.1.1. We have 6 to the power of 2. And then we have two answers. There is 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2, right? And we also have uh, 2 in brackets 2 multiplied by 3 multiplied by 2 multiplied by 3. And then again we have 2 to the power of 6. And we have two options again. Um, which is what? Which is the first one over here that you're seeing, and also the other one. Let me just do this. Um, this and this. So we'll just say this one is our A and this one is our B. So what is going to be 6 to the power of 2? Is it gonna be the first one or the second one? Is it gonna be 2 squared multiplied by 2 squared multiplied by 2 squared? Or is it going to be 2 multiplied by 3, 2 multiplied by 2 multiplied by 3?
Ma'am, you are talking from far. We can't hear you.
You cannot hear me. Is it fine now?
Yes, ma'am. We're just talking from far.
Oh, problem as long as you guys are able to hear me now. So I'm asking for our 5.1.1, which one is going to be the correct answer? Is it going to be 2 to the power of 2 multiplied by 2 to the power of 2 multiplied by 2 to the 2 to the power of 2? Or is it going to be 2 multiplied by 3 multiplied by 2 multiplied by 3?
Ma'am, for 6 to the power 2 is going to be open bracket 2 times 3 close bracket. Wait. Let me calculate.
Okay. Anybody else while she's still calculating? Mana hiyo? Guys, are you able to hear me? Bogang, I'm seeing you for the first time in here. Is it your first time attending?
No, ma'am.
Okay, what's the answer?
Still calculating, ma'am.
Okay. Zira?
Ma'am, is it open bracket 2 to the power of 2 close bracket times by open 2 to the power of 2 close bracket times by 2 to the power of 2 close bracket for number 5.2 and open bracket 2 times 3 close bracket times by 2 times by 3 close bracket for number 5.1.
6.1 point. Oh, sorry, guys. Sorry, not point, but 6 to the power of. I just want to write 6. 6 to the power of 2 is the same as 6 multiplied by 6. Okay. So anything to the power of whatever number, let's say maybe to the power of 3, it simply means that that number it's multiplying itself 3 times. Okay. So in this case, we have a power which is 2. So it's 6 to the power of 2. That means 6 is multiplying itself 2 times. Okay. So it's 6 multiplied by 6. It's 2 6 multiplying together, right? And if you go here, you look at the column B, you have 6 multiplied by 6 being this one when you have removed the squared. And if you look here, the only one that's close or that looks like that is 1. It's 6. It's 2 multiplied by 3 and 2 multiplied, because we know 2 multiplied by 3 is 6, and we know that 2 multiplied by 3 is 6. And then this means that it's the same as 6 multiplied by 6, which is the same as 6 squared. Are we clear?
Yes, ma'am. Yes, ma'am.
So it's 2 multiplied by 3, close the bracket, multiplied by 2, multiplied by 3. So basically, this is 6 multiplied by 6, okay? And when we are looking at 1.2, which is 2 to the power of 6. So this is the same as what? This is the same as 2 multiplied by 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 2. Okay, so it's 2 multiplying each other for 6 times, right? So now if you look here, we have 2 to the power of 2, 2 to the power of 2, 2 to the power of 2. What you can also note from here is the fact that these 2 to the power of 2's share the same bases. And we said when we are multiplying the same base, we add the exponents, right? So if we wanted to simplify this, we would say, okay, 2 to the power of 2 multiplied by 2 to the power of 2 multiplied by 2 is the same as 2 2 plus 2 plus 2, because we said when we are multiplying the same base, we're going to do what? We're going to add the exponent. When we are multiplying the same base, we're going to add the exponent, which are these twos that you're seeing over here. right? Remember, the base is 2 here, the base is 2 here, the base is 2 as well there. And the exponents are 2. So that means it's 2 to the power of, this is the same as 2 to the power of 2 plus 2 plus 2 is equal to 6. Therefore, 2 to the power of 6 is the same as 2 to the power of 2 multiplied by 2 to the power of 2 multiplied by 2 to the power of 2. These are my brackets, okay? And that's it. Any question?
No, ma'am.
Everybody? We all happy?
Yes. Ma'am, can you please zoom a little bit so I can screenshot?
It's fine.
Yes, ma'am. Thank you.
You're welcome. Okay. Now let's move to 5.2. 5.2 says simplify the following. Show all your calculations. And then we have cube root of 127 minus 2. Multiply it by in brackets -5 to the power of 2. So this one I'm not gonna do it straight away. I need to see who's in here. Who's in here? There's Ole and Manahil. Let's start with Manahil. Manahil, are you still there?
Yes, ma'am.
Okay, what is the first thing that we're gonna do here?
We are going to say 127 minus 2, and then which will give us 125, and then we're gonna find the square root of 120 cubic root of 125, and then we're gonna solve the bracket, and then in the bracket we get um -5 times -5, which gives you positive 25.
Mm-hmm.
And then you solve the and then you solve the cube root of 125.
Is it 5? What's cube root of 25? Is it 5?
Let me check now.
Okay.
Yes, ma'am, it's 25.
Manahil, what's the next thing?
So the cube root of 125 is 5.
Mm-hmm.
And then you're gonna say 5 times positive 25,
Which is?
which is 125.
And this is Manahil's answer. Mm, okay, let me tell you something that I used to do now. Um, you see this one over here. I'm not saying you should do that. I'm just sharing with you my my experience, what I did, right? So you see here we have column A and column B, right? And we have 6 to the power of 2 and 2 to the power of 6. And we have 2 to the power of 2, 2 to the power of 2 to the power of 2. And we also have a 2 times 3 and 2 times uh, 3. So let's say, for example, I didn't know how to do this one, but I know one answer of the 2 has to be a 2 multiplied by 3 multiplied by 2 multiplied by 3. So what I would do now, I would write one answer 2 times just so I get 1 mark, because if you sub them you'll lose both marks. But you shouldn't do that because you guys are going to get them right, okay? I'm just sharing with you what I used to do, right?
Yes, ma'am.
And this is Manahil's answer. Thank you, Manahil. Ole, how did you do it?
Ma'am, I said, um, ma'am, like I'm -2 times -5, ma'am. It gives me a positive number. So then I said,
Negative. Where did you get the -2 from?
because ma'am, it's -127.
Yeah.
Yes, ma'am.
So you said, what did you do?
Ma'am, I say 127 minus 2 square cube times 5 to the power 2. Then I said, what is 5 to the power 2, ma'am? And then it's 25. So I said 127 minus 2 to the power, cube times 25. Then I say, then I said, um, then I said 25, one, then I said 25 with 127 to the power 3 minus, to the power 127 cubed minus 2. Then 25. Then I said 127 minus 2. It gives me 125. So when I cube that number, it gives me 5. So I said 25 times 5, and it gives me 125.
Okay. Um, so Ule, we have two numbers here, which is this one and this one, okay? So this one over here, we call it when we have the 3 over here, we say cubed now. So this is what we will call 127 cubed now. And
Yes,
then
ma'am.
mhm. And then when it the sign over here and then there's 3, it's a cube root, né? Because remember this is a square root if it doesn't have this 3, but the moment it has a number it's going to be whatever root. So here it's going to be cube root because this is 3. If it was 4, then it was going to be fourth root, okay? So when you say 125, you cube it, so you are basically meaning that Gosh, what happened? Oh, okay. When you're saying you will cube 125, this is what you mean. And I know this is not what you mean. You wanted to say this, right? So you're going to say you will cube root it. Now, where's my three? You will cube root it. So you cube rooted the 125 to get a 5, right?
Yes.
And yeah, so when it's up there, when the number is up there, it's going to be cubed or square root, but the squared. But the moment it has this, then you're going to say square root or uh, cube root or fourth root, fifth root, sixth root, or any number's root. Name. And another way of showing it that this what I'm saying is valid. This is how do you call this?
To the power 2 or
It's the
squared.
2 squared, no?
Yes, ma'am.
And then what is this?
Cube, ma'am, is it 2 cube squared root of 2?
It's square root of 2, no?
Yes,
So
ma'am.
so when the 2 is up here, we call first, no? But when we have this sign, we call the sign first and then the number after, okay? So if it's 2 to the power of 2, which is 2 squared, we call the square after. But if it's the square root, if it has the sign, we call the sign first and then we call the number. So it's square root of 2, square root of whatever that's inside. So you see there's a common name which is square name. So it's square root
Yes,
of 2 squared. This one is 2 squared and it's square root of 2. So basically this is the root. And then the number will just depend on whatever that's in here. If there's nothing, it's square root. Okay. That is um absolutely correct. And do we have somebody who did it differently, or who would like to show us their method? And remember, this is just 3 marks, so you're going to get 1, 2, 3. Okay, so we don't have to like go further, like with many steps, but it's advisable to have many steps, as many as you'd like to put on your answer book, just so we can pick where you went wrong. Because sometimes if you give me just the answer, let's say for example, Manahil was lazy to write the whole thing, and then they just punched their calculator and then said, um, this whole thing over here is equal to 125. Chances of you getting a mark from this are very low. So this might not even be marked because you're not showing your calculations, you're not showing how you calculated, right? So to lose marks is very simple. Just make sure that you include all the steps. It also helps your teacher to be able to know if they need to help you with something where you're stuck. Okay? Are we good? Are we
yes,
happy?
ma'am.
Perfect. Perfect. And then we have Jolene over here. Jolene remembers her teacher saying, when you divide powers, you subtract the exponents. When you divide powers, you subtract the exponents. Do you guys remember what we said about this? What or do you have an idea of what the teacher meant here? Dolin's teacher meant. Guys,
Yes, ma'am.
do you remember what we said about this? Or do you relate to Dolin? Dolin's statement over here.
Yes, ma'am.
What is it that you exactly remember?
Ma'am, what I remember
Maybe
is
if give an example of what.
okay. So what I remember is that one of the laws of exponents said that if you are dividing, you subtract the exponents. So let's say I have um 2x plus 2x squared plus y over y. What I would do is move the exponent from y because it's a power of 1. Move it at the top, which then will become 1 minus 1. So it's equal to 2x plus y, 1 minus 1.
Like this.
Yes, ma'am. And then what my answer will give me is it's a power of 0, so then it's going to equal to 1. So it's basically 2x squared.
Okay. Okay. Thank you for sharing with us. And let's see. We have Bokang. Let's go to Bokang. Hey, what am I doing? Okay, Bokang ran away. And Manahil, do you remember what we said about dividing? What did we say exactly? What is it that we exactly said?
Ma'am, you said that whenever we divide um the same basis, then you said we subtract the exponents.
Okay. Thank you, Manahil. Thank you. Ole, Okay, guys, I'm back. I'm not really sure what happened. Were you able to hear me? I think I got
Yes,
kicked
ma'am.
out. Which part, hearing me? Or which part did I got cut?
You were talking um about um the minusing.
The statement over here. And yes, I asked Ole. I'm not sure if Ole was able to hear me, but I was able to get what Mana Hill and Zira had to say about this statement. Ole, are you there? Bokang? Okay. Guys, are you able to hear me? Let's see.
Yes, ma'am.
Okay, cool, no problem. Okay, cool. So basically, um, Manahil, you remember exactly what I said. So when you divide the same basis, we less the exponent, we subtract the exponent. When you divide powers, you subtract the exponent. So you see, this statement over here is not true, no? She doesn't remember well, Jolene. She was probably hungry when they were teaching this lesson, and she couldn't hear everything that was being said. So this is what she remembers. When you divide powers, you subtract the exponent. Remember, what are powers? Powers are exponents, so it doesn't make sense, right? Does it?
It does make sense.
It does. Okay. I'm talking about the statement that Jolene says that she remembers. When you divide powers, you subtract the exponent. Does that make sense? What are powers? What are exponents? What is the difference between the two?
Ma'am, the powers are so exponents is like the number of times the whole entire thing is being multiplied by, but the power is like the whole number. It's like the whole the whole number. But
Okay,
ma'am, one thing I wanted to say is that they have to be the same.
they have to be the same. I'm not sure if I get you there.
So ma'am, what I'm trying to say here is like, let's say for instance, n over six, um, uh, n. So I need I need to make sure that the number or the thing that I want, if I want to minus it, I need to make sure it's an n. If it's not, then it can't be. I can't minus the exponents.
Perfect. Basically, the basis has to be the same for you to work with the exponents, right? Whether you are adding or you're subtracting, you have to make sure that the bases are the same. That's what you're trying to say, right? And Jolene here simplified m to the power of 4 divided by n to the power of 6 as follows. So she said m to the power of 4 divided by n to the power of 6 is equal to m to the power of 4 minus 6 divided by n, which equate to m to the power of negative 2 divided by n. And that is her final answer. Is she correct? Let's try to get Manahil here. Manahil, do you think Jolene is correct here? Do you think this is how we're supposed to simplify it?
No, ma'am.
No. And why do you think so? Why do you think it's wrong?
It's because uh no, you would say because if they're not the same base, then you can't minus the exponents.
Perfect. We cannot minus the exponent because we don't have the same bases. One base is the other base is n and the other one is m. So you cannot mix m with n unless if you're multiplying, then you're gonna have mn, right? But not the exponents. So she's absolutely wrong when she says her final answer is m to the power of negative 2 divided by that. And I'm not sure. Hey, what's happening here? And okay. Now you just given the answer for this one. We when we when we divide the same base, we less the exponents, right? So this is already answered. And then they say provide correct answer for m to the power of 4, n to the power of that. Let's see. Um, Boka keeps on running away when I check the names. Ole, Ole, provide the correct answer for m to the power of 4 divided by n to the power of 6. Okay, Manahil, are you able to hear me? Tell me I got kicked out again. Guys, are you able to hear me?
Yes,
Ma'am,
ma'am.
yes, ma'am, can you talk a bit louder? I can't hear you.
Like a little bit louder. So, Manahil, ne? I'm asking you to provide the correct answer for m to the power of 4 divided by n to the power of 6. Was that loud enough?
Yes, ma'am. I'm working it out.
Okay. Ule, are you still in here? What's happening to you? Why are you running up?
Oh, ma'am, I just went to the bathroom.
Mm, okay. Um, okay. Provide the correct
Ma'am,
okay, Manail. We'll come
ma'am,
back.
this has to be one the simplest form.
What?
This has to be the simplest form.
Has to be the simplest form. Yes. Um,
So the answer is m to the power of 4 divided by n to the power of 6.
In its simplest form. That is the answer.
Yes.
Okay, let me note it down here. So Manahil says the answer is m to the power of 4 divided by n to the power of 6. Okay, this is Manahil and Ule.
Ma'am, is it n to the power 6 equals to 0?
N to the power of 6 equal to 0. And how did you get here? This is Ole. How did you get here, Ole? Sorry.
Ma'am, because I asked my mom, then she helped me with this one, but she says she's not sure.
Okay. Manahil. Oh,
Ma'am,
Manahil. Sorry, Manahil. Sorry, I wanted to say Zira. Sorry, you gave me this one. Zira.
Ma'am, this is the simplest form because there are no common bases. So it's going to be m to the power 4 over n to the power 6.
This is Manahil and Zira, and this is Ole and Bokang. And Bokang ran away. Runs away. Okay, cool. So thank you guys. So for this one, Olene, you're just going to rewrite it as it is because you cannot simplify it any further. Remember, I said I'm not sure if you were still in here or you had already left. When Manahil said, when we are dividing the same base, we're going to less the exponent, right? So that is very much important. So that means if the bases are not the same, if we are dividing and the bases are not the same, there's nothing further that we can do, right? So that means we'll just rewrite it as it is because that is already it in its simplest form, okay? M to the power of 4 divided by n to the power of 6 cannot mix each other, right?
Yes, ma'am.
Perfect. So the answer for this is going to be m to the power of 4 and and. Okay. Now let's look at this one over here. They say divide 8x to the power of 5, y to the power of 4, minus 12 to the power of 12x to the power of 2, y to the power of 3, plus 24x to the power of 4, y to the power of 5, by negative 4x to the power of 2, y to the power of 3. How are we going to do this? What is the first thing that we need to do here? Any volunteer? What is the first thing that we're going to do? Thank you. Hello, guys. Are you still here? Or you're still
Yeah. Yes, ma'am, we're still here.
What is the first thing that we're gonna do here? Zero.
I think, ma'am, what we're gonna do for question 4.1 is say 8x to the power 5, y to the power 4, minus 2x squared, y cubed, plus 24x to the power 4, y to the power 5, over 4x minus 4x to 3y, y to the power of 3.
Okay. Just gonna rewrite it. You said 8. Oh no. 8x to the power of 5. Y to the power of 4 minus 12x 2y3 plus 24 24x to the power of 4 y to the power of 5, and we divide everything over minus 4 minus 4x 2y3, like that. And
Then what I did first was I divided everything by minus 4 first. Well, I took it to its simplest form, so basically, what I said x squared. Basically what I said was 2 x to the power 5, y to the power 4, minus 3 3x squared, y to the power of 3, plus 6x to the power of 4, y to the power of 5. So basically, I simplified it by dividing it by 4 over x squared, y to the power of 3.
what happened to the negative?
Oh, yes, the negative, sorry. So it's going to be negative 2, it's going to be positive 3, and it's going to be a negative 6.
So you are saying you are having, okay, let me just write it down here. You are having 2x to the power of 5y to the power of 4 minus 3x squared y cubed plus 6x to the power of 4 and y to the power of 5 divided by negative x squared, negative x squared y to the power of 3. Okay?
Then what I did was that I moved my 2, my 2, right? My exponent 2 up, and what I did was that I subtracted it from my 5, from my exponent 5 over there, and my x squared over there next to 3, and then my x to the power 4. I subtracted 2 by everything with 2.
Okay.
And then for my y's, I subtracted 3, so like 4. My exponent 4 minus 3. My exponent y minus 3. And for y to the power of 5 minus 3.
So you're saying this is what you did: 2x to the power of 5 minus 2 minus 2 minus 3x That is x, guys. X to the power of 2 minus 2 y. Wait, I missed the y. So you're saying y4 minus 3 minus 3x2. Is that what you did?
Oh wait, ma'am, I saw my mistake. I see I can simplify it. So I see -2 and and I see 2 and 6 have the same like they have the same x to the power 5, y to the power 4. So what I can do is add those two together. So it's going to give me 8 x to the power 5, y to the power 4 minus 3x squared y cubed over negative x squared y cubed.
Okay. Do you see that the x here has to the power of 5 and the x here has to the power of 4?
Oh, okay, I see now.
So let me show you like a way, like a simpler way of completing this, right? So this is exactly how you're gonna write it. This over here, I'm talking about this. That's what the expression meant, right? So the next thing that you're gonna do is to check for the highest common factor, right? So you're going to check for the highest common factor. Are you following? I'm gonna have my divide by here. And when I'm looking at these 8, 12, 24, and 4, I can see that a 4 can go into 8, it can go into 12, it can go into 24, and it can also go into 4, right? So that means my highest common factor is going to be 4. So I'm going to have my 4 over here. And then again, if you look at all the terms, they all have x and y, okay? They all have x and y. But when I'm looking at this one over here, um, the maximum number of the maximum power of x is 2 because it's 2 and it's 4 and it's 5. So that means I can simply just say x to the power of 2, right? Because that is the maximum x power. 4x to the power of 2 so far. And then when I'm looking at the y, I have 3, I have 4, and I also have a 5. So the highest power of y is going to be 3 because there's nothing below 3, and then there's 4 and then there's 5. So the lowest is 3. So I'm going to take this 3 over here. So this is going to be my y to the power of 3. Y to the power of 3. Then this is going to be my what we call my highest common factor. Are you guys following?
Yes,
Oh,
ma'am.
Yes. And then now that we got our highest common factor, we're gonna open the bracket. Ne? So whatever that you put in the bracket, this is what you're gonna be saying, telling yourself, what is it that I can multiply this common factor with, this common factor over here with, for me to get what? For me to get 8x to the power of 5, y to the power of 4, right? So we're gonna start one by one. What can I multiply 4 with for me to get an 8? What is it?
2.
2. Perfect. What is it that I can multiply x squared with in order for me to get what? In order for me to get x to the power of 5.
x cubed.
X cubed. Remember, when we multiplying the same base, we add the exponent. So x to the power of 2 multiplied by x to the power of 3 is going to be x to the power of 2 plus 3, which is x to the power of 5, right? And then let's do the same thing for y to the power of 4. What is it that I can multiply the y to the power 3 with for me to get a y to the power of 4?
Y.
Y. And okay, now let's move to here. All right. What is it that I can multiply 4 with and I get a negative 12?
-3.
Negative 3. Negative 3. What can I multiply x squared with for me to get x squared?
Nothing, ma'am.
1. Ne? Ne?
Yes, ma'am.
Yes. So I can multiply 1 with x squared, then I will get when I multiply x squared with 1, I will get x. X squared. Remember, when you multiply anything with 1, you'll get that very same thing. But because there's already 3 here, I'm not going to put a 1 because it's going to be 31, okay? So that means I'm going to leave it there, right? I'm not going to write anything, all right? Because there's other things. If there's other things, you don't write 1. But if it's just it, maybe let's say, for example, we had minus x squared. Then I was just going to say minus 1, okay? Then we leave it like. But because there's something y to the power of 4, so already this is going to be there because we are multiplying with it. And then we have y to the power of 3, which is here, this one over here. So I'm going to go to my highest common factor, which is here. What can I multiply the y to the power of 3 with for me to get the y to the power of 3?
1, ma'am.
1. So I'm not going to write anything because there's already 3 here, right? And then let's go to positive 24. What can I multiply 24 with for me to get a what can I multiply 4 with for me to get a positive 24?
+6.
6. Everybody, are you following? Plus 6.
Yes, ma'am.
Right? And then what can I multiply x squared with for me to get what? To get x to the power of 4. Manahil, I haven't heard you in a very long time.
Yes, ma'am.
What can I multiply x squared with for me to get x to the power of 4?
You must multiply x to the power of 2 to x to the power of 2. You add the exponents.
Perfect, Manahil. So I'm going to have x to the power of 2. And we have y to the power of 5 here, Lene. So what can I multiply y to the power of 3 with for me to get y to the power of 5? Ole?
Y to the power 2.
Perfect. And I'm just gonna close my brackets because everything has been captured, right? And then let's see. Down here we have minus 4 x to the power of 2, y to the power of 3. So if you have something like this, can you see that we have like terms? This and this are the same, but obviously this one has a negative. So there's a negative, but this and these are the same. Do you guys see that?
Yes, ma'am.
Basically, when they are the same like that, we can cancel them out. They can cancel each other, which is going to be ka ka. So that means we're going to be left with whatever that's in the brackets and the negative over here. Okay. So in the bracket, we have what? We have 2x to the power of 3, 3y, 2x to the power of 3y. Mm-mm. Okay, it's 2x to the power of 3y minus 3, and then plus, what was it? Was it 6? 6x to the power of 2. I think Ole said y to the power of 2 as well. I think so. And then divided by -1. I'm just going to try to verify if yes, it is. Cool, cool, cool. And divided by -1. So when you are dividing with a -1, everything at the top is going to change the sign. If it's negative, it's going to become a positive. If it's a positive, it's going to become a negative, right? So that means we're going to have -2x to the power of 3y plus 3 minus 6x to the power of 2y to the power of 2. And this is going to be our final answer. Do we have any questions before I end the lesson?
Ma'am, can I ask a question?
Yeah, boo.
Ma'am, when are we going to do the geometric patterns?
Geometric patterns. I'll check the thing, the planner and see when exactly we're gonna do those. Are you
Okay, ma'am.
struggling with them? Is this Bokang?
Yes, ma'am.
Oh, okay. Okay. But we've done them before. I'm just not sure. Have you? Is it recently that you've joined?
Excuse me, ma'am.
You joined recently.
No, ma'am.
Don't remember seeing you. Eh? Okay, cool. Any other question? Manahil, are you good? Are you happy? Ole, are you fine
Yes,
there?
ma'am.
Okay, Zira.
I'm fine, ma'am. Thank you.
Good. Okay, guys, enjoy the rest of your week at school and this evening. Bye, guys.
Bye, ma'am. Thank you.
Bye, ma'am.
Okay.